This week on the show, this is the actual week where we do a lot of ZFS, fear, uncertainty, and doubt removal, hopefully. Show you how to write a NetBSD kernel module and cover DragonflyBSD on the desktop. So something for everyone in this week's episode of BSD Now. BSD Now, episode 203, For the Love of ZFS, recorded on the 19th of July, 2017. Hi, I'm your host, Benedikt Reuschling.
And I'm Alan Jude.
And we have a great episode prepared for you this week, as always, but the first thing is always the headlines, and we should get right into them now, because there's something for Alan to talk about, because there is ZFS is the best file system posting on blog.fosscats.net, and yeah, it starts with ZFS best file system now, ? And what's this about, Alan?
Right. So there was a blog post that came out last week around the time we were doing the show, actually, where someone had written a blog post about ZFS. And I was like, oh, okay, I'll check it out. And it seems that they had caught some impressions that aren't necessarily true about ZFS. And I thought we'd maybe iron some of that out.
Yeah, by all means.
Yeah, so they started off saying, ZFS should have been great, but I kind of hate it. I'm like, whoa, now you have my attention.
Let the
They
rant
say
begin.
ZFS seems to be trapped in the past. Before it was sidelined, it was a cool storage project of choice, but it's inflexible, it lacks modern flash integration, and it's not directly supported by most operating systems. I'm like, but none of those are true. How?
Shots were fired.
But I put all my valuable data on ZFS because it simply offers the best level of data protection in a small office/home office environment. And they go on to explain why and how to check something works and so on. So they talk about how ZFS started and then went public and so on. And then it was the skies first darkened in 2007 when NetApp sued Sun, claiming that Sun had infringed on some Waffle patents. Waffle's NetApp's file system based on FreeBSD. They say Sun countersued later that year and the legal issues dragged on, but they were all resolved, and it turns out nobody was infringing on anybody. And it turns out that didn't really impede ZFS. Some say it was the reason Apple didn't go with ZFS, while others say that it was because Sun announced it before Steve Jobs did, and Steve Jobs wouldn't have that. There are many theories of why Apple, at the last minute, decided not to go with ZFS. All we know is that it was to the detriment of the world. Anyway,
Yeah.
but then Sun was hitting hard times and Oracle swooped in and purchased the company. This sowed further doubt about the future of ZFS, which I agree, it kind of did, since Oracle did not enjoy wide support from open source advocates and, Oracle decided to close up the source code. That kind of puts a damper on things. So yes, Oracle taking over Sun and closing the source of ZFS definitely seemed like a setback at the time. Lots of people were quite worried about it. But very quickly, the OpenZFS project showed up, which is basically a fork of the last open source version from Sun, and turns out that kept it going. And they started active development, and that's continued on and has gotten ever accelerating pace from that. And as of today, more than half of the code that's in OpenZFS was written after the fork. So half of the code that's currently in ZFS is newer than when the fork happened.
Mm-hmm. Yeah,
So some of that is replacing old code and some of it is adding new code. But either way, obviously OpenZFS is not stagnated now that it's not under Sun, because we've added or modified 50% of the code base. That's kind of a lot. There is the issue that the CDDL license from Sun that applies to ZFS code was judged to be incompatible with the GPL v2 that covers Linux, and therefore is a non-starter for inclusion in the world's server operating system. I would argue with that particular thing, but that's for another day. But that really hasn't stopped the ZFS on Linux project, or Ubuntu, or anybody else from shipping ZFS. So, we'll have to see. But in general, ZFS is available for Linux, and Ubuntu is shipping it. So it's not as impossible to run ZFS on Linux as that makes it sound. They say, although OpenSolaris continued after the Oracle acquisition and FreeBSD embraced ZFS, that was pretty much the extent of the impact outside of the enterprise. They say, sure, Nexenta Store and the Green Bytes helped push ZFS forward in the enterprise, but Oracle's lackluster commitment to Sun in the data centers started having an impact. It's like, well, lots of companies have actually adopted OpenZFS in their products. Before OpenZFS, there weren't really many appliances other than Sun, but nowadays there are plenty. The OpenZFS wiki has a giant page full of companies, and it's actually not that up to date, so the number of companies is quite a bit bigger than that list. There's a lot of things using ZFS. There are even off-the-shelf NASs you can buy at your big box store that runs ZFS now. It's a lot bigger than he's making it sound. Then the next point he had is that OpenZFS remains little changed from from what we had a decade ago. It's like, well, I know a whole bunch of people that would argue otherwise. If you take any ZFS user and give them a version of ZFS from 10 years ago, they will definitely notice missing features.
Yeah.
There's a big difference. It was funny. I was actually talking to somebody today who was using ZFS version 22, which would be like FreeBSD 8.2 or something like that.
Yeah. Oh, zpool upgrade and stuff.
Yeah. So they didn't have the async destroy feature, which was in, I think, v28. So when they do a destroy, it takes forever until you get the command prompt back. And they had to reboot. So they rebooted, and now when it boots up, it starts importing the pool, and it just hangs there while it finishes that operation. It's like, yeah, you really, really wish you had async destroy for that.
We've been over this. Yeah, this is done now, or finished, or solved.
Yeah, so lots of changes to ZFS in the last 10 years.
Good ones, yeah.
And, like we just mentioned, half the code that's in ZFS today didn't exist 10 years ago. There's a lot that has changed.
Time has moved on, and the code has been evolving.
Now, some of the points he raises are valid. Some of them we have an answer to. Some of them we have an idea of how to answer it, but don't actually have an answer to yet. So the first one he brings up, obviously, is that many remain skeptical of deduplication. And yes, that is true. It says, which hogs expensive RAM in the best case scenario. So, yes, this is one of the weaker points of ZFS. But as it turns out, the demand for deduplication is not actually that strong. There are lots of ideas on how to fix it, but nobody's done it because nobody's needing deduplication that strongly, really. It turns out compression does most of the savings for you and is a lot cheaper and easier and safer. When you can get most of the win by just using the transparent compression, there's not much point spending time on fixing dedupe. But there are a couple of designs out there for fixing dedupe. The first is just called dedupe ceiling. The general idea here is you will set a size limit on the dedupe table, and when you reach that, it will just stop deduping. Any newly written blocks will just not be deduped. They'll be treated as if dedupe was set to off. So you will get the advantage of dedupe on up until you have so many unique blocks that whatever amount of RAM you specify is taken up by the dedupe table, and anything else will just not be deduped. So you get some dedupe, especially in the beginning, when maybe that's, when you're first starting up your VMs is most likely when you're going to get most of the value-added dedupe anyway. And then after that, it'll just turn off. Intel is working on another feature called allocation classes. This would allow you to decide, this type of data goes on this VDEV and this type of data goes on that VDEV. Intel's developing it for a supercomputer they've been contracted to build. And it allows different types of data to be classified and have dedicated VDEVs or even just metaslabs within a VDEV to that type of data. That could be extended to say, hey, the entire DDT will live on this fast PCIe NVMe device. We'll just have, an SSD or an NVMe dedicated to holding the DDT. It'll be fast enough that you won't get the performance penalty you get now of it falling down to being on, spinning disks. And if it's always there, you won't get this. The problem with it is now is if it's in RAM, everything's really fast, and then suddenly as soon as you get one more block than can fit in RAM, you just fall off this cliff. Whereas if it's just always on an SSD or an NVMe, you get consistent performance. Yeah, plus, you combine that with the dedupe ceiling so that when that NVMe gets full, you just turn off dedupe until maybe you can add another NVMe and, raise the ceiling, and then you can start deduping again or whatever. Another interesting idea was DDT pruning. So at the FreeBSD Storage Summit in 2016, Matt Ahrens described a design where, so you have your DDT, and every time you write a block, the hash of that block goes on the list, and we have one reference to it. And if you're going to add a block and its hash is already on the list, then you just increment the reference count, right? And you say, oh, there's 2 copies of this block. And you end up not writing it to the disk and just referencing the existing copy. With this, if we're out of space, if we've hit the ceiling on dedupe, then what it does is it deletes the least recently used item from the dedupe list that has only one reference. So some file or some block that's already been written but has never actually managed to find a duplicate. We take it off the DDT list. Now, normally this would cause bookkeeping problems because you have to make sure that it's not a dedupe block when you go to delete it. But if you check in the DDT and it's not there, you know that it was a block that only ever had one reference, and so it's safe to free. So this way, every time we want to add a new block to the DDT and it's already full, we find some file or some block that hasn't managed to be deduplicated yet, delete it, and insert this new block, in the hope that that new block will have a better chance of finding a duplicate. Right? If a file has never been duplicated in the last 2 years that it's been sitting on the disk, the chance of it being duplicated later is pretty low, compared to some new block that stands a decent chance of actually being duplicated recently. If you think of VMs and they're all installing the same Windows update or something, or the same OS update, that newly written one is probably going to be duplicated pretty quickly.
So that's the pruning part?
Yeah, so basically you delete items that have had a turn on to be deduped but have never managed to do it. You delete them in hopes that the new block coming in stands a better chance of actually deduping. And so in this case, you hope to end up with a dedupe table full of only blocks that are actually stand a chance of being deduplicated. Obviously, this still falls down if you end up with so many duplicated blocks that you run out of RAM, but
yeah.
If your DDT ratio is that high, then
it's a good approach to solving that. Okay.
Yeah, so that's an interesting approach to that one as well. And there was also some ideas on how to manage the actual dedupe data, metadata, by using a log instead of the way it works now. So he goes on, he says, and I do mean expensive. Pretty much every ZFS FAQ flatly declares that ECC RAM is a must-have and that 8 gigabytes of RAM is the minimum amount. In my own experience with FreeNAS, 32 gigabytes is a nice amount for an active small ZFS server, and this costs $200 or $300 even in today's prices. It's like, well, I don't want to come off sounding elitist or something, but $200 or $300 is not expensive.
Well, for ECC RAM compared to the non-ECC.
ECC RAM versus not ECC RAM, the price difference isn't that big.
Yeah. There's someone who bought...
and, yes, 8 gigabytes is probably a good guideline for a minimum. You can go less than that, but only if you really think you want to do that. Well, they'll get into that in a minute, but as we talked about just the other week, ECC is best. You should have ECC, but it's not required. If you want your server to stay up for a long time and not crash, ECC RAM helps prevent that. And if you want high availability, then you need the server not to crash and ZFS not to screw up. So you want ECC RAM. But in the end, don't let a lack of ECC RAM stop you from using ZFS.
Yeah, it's not a hard requirement.
If you end up using something other than ZFS, you're putting your data at more risk than if you were using ZFS with non-ECC RAM.
Yep.
In the end, ZFS is good, ECC is good. You should use both. But you can use ZFS and non-ECC RAM. It's going to be fine.
Yeah, that's important to be said and to be heard.
And in particular,
tweeted out.
The scrub of death is a myth. Next week or so, I will have an even bigger spiel on the scrub of death thing, where I have an actual archive answer of this from Matt Ahrens himself to explain how that's not how it works. So we'll put that one to bed, even harder next week.
Once and for all.
Yeah. So, but ZFS does not require lots of RAM. Your NAS will work happily with 8 gigs of RAM instead of 32, right? He said he has 32 in his, but yes, it'll work perfectly fine with 8. It's just your cache hit ratio will be much lower, and so your performance will be worse, and you won't be able to buffer as many writes, so your performance will be worse. Copy on write has some drawbacks. The important thing that copy on write gives you is your file system never gets screwed up because you're never overwriting it, so you never end up with a half overwritten system. You always have the ability to go back one step sooner and have a perfectly working file system. That's why copy on write is good. Why it's bad is it ends up spreading the data all over the disk, and you can end up having to do more random seeks to read the data. ZFS tries to overcome that by having the ARC, the RAM cache, and that lessens the pain of the seeking by having prefetch, so that when you start reading the file, it can start getting the later parts of it before you even ask for them, so that when you do ask for them, it's fast. And by just keeping the most frequently used and most recently used stuff in RAM. So more RAM is more better, but it's not required. ZFS also alleviates the pain for writing by batching incoming writes up into nice contiguous writes. So it turns out, especially with spinning disks, that writing while you're trying to read slows things down. Just like reading while you're trying to write slows things down. And also writing randomly slows things down. So what ZFS does is it bulks up a bunch of data until either the amount of data gets too large or the timeout of the default 5 seconds runs out. And then it takes all that data and tries to write it one contiguous block if there's enough free space. It just write it all out really quick. So what it does is it spends all of its time reading and doing no writes, buffering it all up in RAM, and then when it hits one of the triggers, it'll stop reading, do all those writes as quickly as possible, and then start reading again. Now, obviously, if you do synchronous writes, like for a database where you say, I need this on disk safely ASAP, then it'll interrupt that flow a little bit. But that's where the slog comes in, where you can actually write that out to an SSD and then batch it in later. But anyway, the point is that interleaving the reads and writes like that improves performance. And you can do bigger, more efficient batches if you have more RAM. But again, ZFS is not going to break because you only give it 8 gigs of RAM. It's just not going to be as fast.
And it's an adaptive replacement cache. It's dealing with the amount of cache
what it's adapting to there is by having a most recently used and a most frequently used cache and balancing those and having the blacklist. It's the adaptive doesn't mean the other thing. Although, yes, it will free up memory if you need it. But in general, you can tune ZFS to use less RAM. And if you don't have a lot of RAM, maybe that's something you need to look at a little bit closer. And the other thing is, if you have something that demands a lot of RAM, right? If you're running a database on top of the file server, then you're going to want to leave the database some RAM. Anyway, back to the article where he says, ZFS never really adapted to today's world of widely available flash storage. Well, first of all, there are plenty of flash-only ZFS pools and even ZFS appliances that you can just buy. IX sells a flash-only TrueNAS for under $10,000. But he says, although flash can be used to support the ZIL and the L2ARC caches, the ZIL, or ZFS intent log, is not the thing you put on an SSD. That's called a slog. The ZIL is something that always exists. Normally, it's part of the pool, but you can put it on a separate device, or the S-log, separate log device. When you have it on an SSD, that's not called the ZIL, that's called a slog. The ZIL is something you always have. It's not an optional thing. Anyway, they say, these are of dubious value in a system with sufficient RAM. It's like, yes. The entire point of the L2ARC was that if you can't put any more RAM in the system because there aren't physically enough slots or the processor doesn't support more RAM or you can't afford more RAM, then that's what the L2ARC is for. If you can just buy more RAM, then you don't want an L2ARC. That's actually the point. But that's one of the parts that confuses me. It's like, well, a minute ago, 32 gigs of RAM was too expensive. Now it's like, well, I could just buy more RAM. It's like, well, if you can afford that, then yes, go ahead, do that. It'll be better. But an S-log isn't helped by having more RAM, because the whole point of the S-log is when your database says, I need something written down on disk, not just in RAM in case the power goes out, more RAM doesn't help there. Anyway, it goes on that ZFS has no true hybrid storage capability. What file system does? None that I know of. And ZFS is getting there, though. I think ZFS will be the first one that's commonly available file system, especially open source, that will be able to do hybrid storage. And we'll get to that in a second. He says, it's laughable that the ZFS documentation obsesses over a few gigabytes of SLC flash when you can get multi-terabyte 3D NAND drives on the market today. Yes, but the S-log is special. It never needs to be more than a few gigabytes because it's just buffering writes temporarily until they can go to the regular storage. So if you buy a multi-terabyte 3D NAND device for your slog, you just wasted a bunch of money. The other reason for SLC flash for that is write endurance. You're going to be overwriting it all the time. You want one that's going to last. You don't want to have to buy a 3 terabyte 3D NAND device and only use 10 gigabytes of it in order to be able to meet the write endurance requirements. So yes, a few gigs of SLC flash is what you want for your S-log. If you can afford a bunch of multi-terabyte 3D NAND devices, just make your whole pool out of those. And you'll get lots of speed. And you won't even need an S-log. He goes on to say that, nobody's talking about using NVMe devices with ZFS. It's like, well, mostly because there's nothing to talk about. You just do it. I know lots of people that have ZFS pools using NVMe devices.
zpool create, and off you go.
You just use it. Like, other than maybe needing to tweak the queue depths in order to take the full advantage of the NVMe device, there's nothing else you have to do in ZFS. It just works. But to say that nothing is happening in this space would be woefully inaccurate. As we previously mentioned, the allocation classes code that Intel's working on can also be used for other things. For example, in their supercomputer, they will allocate metadata, little 4K blocks of metadata, on SSDs or NVMe devices, while they write the bulk scientific data in 16 megabyte blocks, again, another feature that didn't exist 10 years ago, to spinning disks. So on their spinning disks, they'll do giant 16 megabyte blocks. And with spinning disks, when you're doing huge blocks like that, and they're all going to be sequential, your throughput's going to be great. And then the 4K metadatas are all going to the SSD. So they actually have hybrid storage where small data goes over here and big data goes over there. But with extending that a little bit further, you'll be able to create hybrid storage with ZFS. With the meta slab classes feature, you'll actually be able to mix the different classes on the same device. So, in case people don't know, on ZFS, when you create a device, on the VDEV, it divides that device up into about 200 chunks called metaslabs. And so, if it's a 1 terabyte disk, you'll divide it into 200 chunks. And then space is allocated from those. With this allocation class feature, you'll be able to say, this metaslab will only be used for like 4K blocks. And this metaslab will only be used for like 128K blocks. And you have other metaslabs that take the other stuff. And this could help reduce fragmentation by trying to group blocks of similar sizes together so that they don't end up with weird gaps between them and so on. So even that can help improve performance and decrease fragmentation without having to use separate devices. So it'll be good in both cases. So then he gets to some of the other complaints he has about ZFS. He says, then there's the question of flexibility, or the lack thereof. Once you create a ZFS pool, it's pretty much fixed for life. There are only 3 ways to expand your pool. Number 1 is replace each and every drive in the pool, well, in the VDEV, not the pool, but with the larger one. And he says, this is great, but limiting and expensive. It's like, well, it depends on your perspective and how many disks you're talking about. In my system with 36 disks, where it's 6 sets of 6 disks, I only have to replace 6 at a time to get extra space, and that's not necessarily that expensive. But it depends how quickly you need more space, whether replacing, say, 1 and 2 terabyte drives with newer 6 or 8 terabyte drives, they're getting old anyway. Maybe I want to replace them, and so it's not actually expensive. But yes, that has some limits to the flexibility.
But storage needs to be planned anyway. You just don't slap a couple of disks together.
If your plan is to need to keep adding storage or being able to upgrade storage quickly, you'd want to use ZFS mirrors so you can replace just 2 or 3 drives at a time and get the extra space and have more flexibility. Sure, it ends up costing a bit more because you have less usable space, but it gives you that flexibility.
It's always a trade-off somewhere.
Yeah. Number 2 is add a stripe of yet another set of drives. Yes, that's the main way you expand ZFS. The entire point of ZFS is that you just keep adding more drives to the pool. Yes, you have to do them in groups, but again, that just comes down to planning. He notes that adding an extra set of empty drives can lead to imbalanced performance and redundancy and a whole world of potential stupid stuff. Actually, that's gotten a lot better over the years. The unbalanced lens performance issues were sorted out in increments from 2013 to 2016. It turns out a lot of people that use ZFS add more storage. One of the reasons they use ZFS in the first place. One of those was Delphix, where they make a database appliance. Turns out databases eventually get bigger, and you need more space. When you add an empty device, you don't want all your writes to only go to the empty device because it hurts your redundancy a bit. And more importantly, you're not getting the performance of 2 devices, but only 1 or more, depending on your setup. So they have, I've linked here, they have first in 2014, George Wilson did the ZFS allocation performance, where he dealt with a bunch of that. And then there's a later version from 2016, where Matt Ahrens and George Wilson presented ZFS space allocation, doubling performance on large and fragmented pools. Talk they give at BSDCan, where there's video and everything, and they talk about how they further improve this and how they've got plans to go even further to make this even better. On top of those, on top of fixing the unbalanced LUN thing, the other thing that these performance changes they did and allocator changes they did mean that they've mostly solved the performance issues as your pool gets full. So your pool performance no longer falls off a cliff at 75% or even, 80% anymore. You can go a lot closer to full before the performance falls off a cliff now. And it mostly comes down to depending on your devices and how quickly they can deal with it and how fragmented your pool is and so on. But things are definitely a lot better than they were even just a couple of years ago.
Definitely, yeah.
And number 3, he says, is build a new pool and just use ZFS send to replicate it to the new pool. It's like, yes, that's one way to do it. There's also going to be an even better way, but it's not announced yet, so I can't really talk about it. But soon, there will be big news on this front about expanding pools.
Oh, yeah, I know what you mean. Yeah.
And then the other one they look at is shrinking a pool and saying, hey, well, that's currently not possible. It's like, well, actually, VDEV removal is coming. It's been in Delphic's version of ZFS for a while. It won't work on RAID Z, but if you're using mirrors or stripes of devices, especially, in Delphic's case, they use LUNs from a SAN as backing their ZFS, you will be able to actually remove a device. In particular, if you accidentally add a single disk to the end of your RAID Z by accident, you'll be able to undo that. So, we're getting there on that front as well.
Good.
So he goes on, he says, I've probably made ZFS sound pretty unappealing right about now. It was revolutionary, but it's now startlingly limited and out of touch with present solid-state dominated storage world. I would argue that solid-state has not dominated the storage world. If you need to store large amounts of data, flash is just not an option. And if you need high speed for, say, backing VMs, all SSD is an option. So while ZFS doesn't have a great answer for hybrid storage just yet, it's coming though. It's not like anybody else has a great answer to this.
Yeah, it's the same problem if you look at other storage solutions, and ZFS is closer to the new way of doing things than any of the others I've seen. And I mean, just look at the way that the L2R could increase the write speed by just acknowledging the writes that the application is doing. And then over time, they trickle down to the actual big storage disks. And the applications can continue knowing full well that the L2ARC has all their data stored. And that's already something you cannot do currently in other storage systems in the Unix world, as far as I can tell.
Yeah, so I'd say I don't feel like ZFS is actually out of touch with solid state. I think maybe this guy in particular has just not heard very much about how it's being used with solid state. And, there are companies out there that make huge flash arrays, and they're there, and they're not as expensive as they used to be. So if you want all flash, that just works. And if you can accelerate things by just having more RAM, spinning disks with more RAM and maybe some SSDs is the right mix. But yes, hybrid's not quite there yet, but show me a better open source file system that has those features for hybrid, and I'll show you where it's not as good as ZFS. So, a lot of work is being done to allow ZFS to overcome the few things that he pointed out here. He says, after all, reliably storing data is the only thing a storage system really has to do. Everything else is just icing. All of my important data goes on ZFS, from photos to music to movies and office files and everything. And it's going to be a long time before I trust anything other than ZFS. So that's his words, not mine. I completely agree. ZFS has a track record for doing its most important job, keeping your data safe. Other file systems, not so much. Work is ongoing to make ZFS more performant, more flexible, and to address the hybrid requirements. The important thing is that this work is never allowed to compromise job number one, which is keeping your data safe. Hybrid / tiered storage, re-rating, etc. Those are coming. We'll get to there.
Soon. Or soon enough.
But as to the idea that ZFS is stagnated, totally not true. Lots of things going on. There's a lot going on in OpenZFS. All you have to do is even just look at the notes from the Developer Summit. I got the links for 2015 and 2016 here. Lots of stuff going on. In fact, the schedule for 2017 will be up soon. If you're doing something interesting with ZFS, make sure you submit a talk so that people will be able to see it.
Yeah.
Just to highlight some things that have happened recently or that are actually going on in ZFS right now, we have the compressed arc.
Which is awesome.
This is a feature that's
Thanks
in
for that.
FreeBSD now. It's amazing. So if the data is compressed on disk, keep it compressed in the cache, and then just decompress it as it's used by the application. This means you can keep somewhere between 1 and 3 times as much data in RAM as you could before, if you were decompressing the data on disk before you put it in the cache. So,
I run top much more these days, looking just at these stats.
Now you can fit more data in the same amount of RAM. So however much RAM you put into your ZFS machine, it now holds more in cache, and you get free performance, basically. Then that led to compress, send, receive. If you're doing replication, why decompress the data, then send it over the network, and then recompress it when you could send it over already compressed? Huge win there too. ABD, or arc buff data. This is a way to do scatter-gather lists and build the large blocks of memory in ZFS out of smaller blocks, like 4K pages. This is mostly driven by Linux's requirement that the Linux kernel can't handle very large allocations of memory, but it might be useful for other things as well. That's already in even FreeBSD now. ZFS native encryption, that's coming. That'll give you the ability to scrub or resilver, send and receive, etc. encrypted data without even having to have the encryption keys loaded. So you can have a data set that can be encrypted at rest and is still protected by its ZFS checksums, can still be scrubbed and resilvered, can still be backed up and replicated, but only people with the key could actually mount it and read it. So that means your ZFS backup, replicated to offsite, doesn't have to be able to be decrypted. It's great. Channel programs, being able to do multiple administrative operations in a single atomic transaction. Whole talk at BSDCan about that. Very interesting stuff happening there. Device removal. That's in Delphix. It'll be upstream and in FreeBSD pretty soon. Redacted send receive. So at Delphix, they had the need to replicate all their database, but they wanted to remove the credit card numbers first. So the credit card numbers were not in the backup. That's a pretty interesting feature. Basically, you clone the data set, overwrite the credit card numbers with zeros in your database program. It then uses that as a mask to filter the data and replicate the original data set without the credit card numbers. It's actually really cool. Z standard compression. If all this compression is great, what if we had even better compression? Trim support. So FreeBSD has had its own trim support in ZFS for quite a while now, but this is a general one in ZFS that'll be supported on all the operating systems, and it's a bit more performant and more universal, and has more ZFS-specific tuning, so that'll be interesting to see. Faster scrub and resilver. Who doesn't want that? I have a link in the show notes to a whole video about it. It's really interesting. The approach is pretty straightforward, but makes a lot of sense and is quite interesting. Intel's also working on declustered RAID. So instead of your regular, RAID Z or whatever, this one, they have a supercomputer that has, say, 100 disks. And instead of breaking those up into a bunch of separate VDEVs, they do it kind of virtually. So that when one disk dies, they start resilvering to a virtual spare made up of space scattered across all 99 other disks. So that the resilver time is very quick, because what they're actually doing is reading from and writing to all 99 disks at once to get back to that safe state of having all 100 disks. Anyway, lots of interesting stuff going on there. The allocation class stuff we talked about, multi-mount protection. If you're doing like active-passive failover, where you have two different servers attached to the same block of chassis full of disks, this will be a ZFS feature to make sure you don't ever accidentally mount on the second machine while the first machine is still active. Basically, a ZFS-specific way to make sure to mediate those two machines to make sure they share the disks nicely. Zpool checkpoint. We talked about this a month or two ago.
Couple of shows
basically
before,
allow you to checkpoint the pool, do some stuff, and if it doesn't work out, roll it back. Basically allows you to undo almost anything in ZFS, including adding a disk. You can undo adding a disk. You can undo deleting a dataset. You can undo renaming stuff, all that stuff. Even undo creating a dataset, which is different than just deleting it. Even more improvements to the allocator performance. VDEV space map log to have more performance there and also more recoverability. ZIL performance improvements with or without an S-log. So this is, I think, Alexander Motin is working on some stuff with having using very fast flash storage and getting more performance out of it for the S-log and the ZIL. And Nexenta is also working on a persistent version of the L2 ARC. Currently, one of the drawbacks of using SSDs for an L2 ARC is that when you reboot, they start out empty and you have to refill them. This would allow them to persist by basically reloading the headers off of them in the background at boot up. So not immediately at boot, but over some relatively short amount of time after you boot the system up, all the stuff that was in the L2 ARC will reappear and be remapped out of the ARC.
Yeah, the ZFS future looks very bright from my perspective.
What I don't think the author of this original article understands is, A, how much stuff is actually going on in ZFS. Maybe we're just not making a big enough deal out of it. I don't know. He mostly seems to be a little bit more on the Linux side, and is maybe just, I don't know. Maybe it's just that when you go to a FreeBSD-based event, everybody's talking about ZFS, and if you go to a Linux one, most people don't even know what ZFS is. And maybe that's a lot of it. I don't know. But ZFS is definitely very healthy and is very active development. It's definitely not stagnated, and it's going places. And it's already so far ahead, with hundreds of engineers' years of work that have gone into ZFS, and the pace is only getting faster. I don't see how some of these other systems are going to catch up.
It will be difficult to at least see the backlights of ZFS car rushing along.
Yeah,
it's great to be part of this and have those features available in FreeBSD and also other systems that are using OpenZFS. And the irony is actually, for me, is that Oracle is backporting some of these features like the LZ4 compression.
Yeah, well, that one was definitely funny when Oracle's version of ZFS got LZ4 like 4 years later. It's like
and it matured a little bit in OpenZFS.
I forgot you didn't have
pull down. But by that, everyone is like, we're done that already. Can we move on? It's the irony is there definitely.
Yeah, so the comments have a couple of concerning statements, including people who think that the ECC on hard drives means that you don't need ZFS. It's like, well, if you read the datasheet for the hard drive, it says that it won't be able to correct the error once every, 10 to the power of 14 or 15 bytes. Well, if you look at the size of the disk, that's every pretty often. And you're going to want ZFS. Also, what ZFS does to the data is not a CRC. It's an actual checksum. There's a difference. Couple other things in here. Then I saw an interesting one from Paul Vixie.
Oh.
And he quotes from the article, and no one is talking about NVMe. It's like, This is Paul Vixie now. I was just talking about NVMe and tiered hierarchical storage to make appropriate use of solid-state disks in ZFS about a week ago, which would not be meaningless which would be meaningless since I'm not a ZFS developer, except the person I was talking to was Kirk McCusick, who's the original author of FFS/UFS and close friends with Matt Ahrens, actually, and now FreeBSD kernel developer. And he had this gleam in his eye. I want my spinning rust gone and my power bill lowered. When NVMe offers memory mappable persistent storage, I want my file system to take advantage of it. mmap should mean no block level data moves at all. Well, Bcachefs sounds interesting, so on. My bet is on ZFS. He says, I'm exceptionally pleased and proud that FreeBSD went all in on ZFS, and I'm looking forward to whatever they come up with next.
Yeah, I mean, I'm so happy that ZFS is here. It takes care of all my data. I sleep very well at night, knowing full well that ZFS keeping all that stuff secure. Plus the icing on top, the features, the compression, everything else is just marvelous.
Yep. Anyway, we can't talk about ZFS for the whole show. So
as much as we like. Yeah, we have other news, of course.
But anyway, I guess one thing to point out quick was I've linked to the wiki pages for the OpenZFS Dev Summits from 2015 and 2016. They have slides and video for each of the talks. Lots of interesting stuff in there. They also have the list of topics from the hackathon, which gives you an idea of other things people are thinking about that aren't necessarily on the roadmap yet. And then for 2016, again, same thing. And shortly, there will be the list for 2017. The OpenZFS Dev Summit for 2017 will be in October of this year in San Francisco again.
And we have a lot of stuff that Alan talked about in the show notes and linked from there, videos, PDFs, everything you can watch and read quietly on your own for much more about ZFS. Okay, now on to the next point, which is writing a NetBSD kernel module. So this is on GitHub, a blog post probably, or looks like it. So it starts off with kernel modules are object files used to extend an operating system's kernel functionality at runtime. So where you can dynamically load modules into the kernel and extend the functionality somehow. In this post, we'll look at implementing a simple character device driver as a kernel module in NetBSD. Once it is loaded, user space processes will be able to write an arbitrary byte string to the device, and on every successive read, expect a cryptographically secure pseudo-random permutation of the original byte code. Byte string, not byte code. So with that, you need the NetBSD source code, of course, because you need to compile the basic operating system sources for that. And compiling the kernel module requires NetBSD source code in user source, but there are instructions linked there how to do that. And usually most user space interfaces to character or block devices are through special files that live in /dev, of course, and we'll create one such special file through the command makenode, mknod, def rperm. C is the character device parameter, and 420 is the permissions, and 0 is, I don't know.
420 is the major number, and 0 is the minor number.
Right. We don't have that in ZFS or in FreeBSD anymore.
Yes, in FreeBSD we have DevFS that auto creates all this stuff on demand. But yeah, so you're creating a kernel module, and then they get into the source code here. Basically, they're going to implement just the bare bones of what you need, the open and close syscalls and the read and write syscalls. And then you see here, there's a struct where you provide pointers to those functions and then provide errors for the rest. And then there's a little bit of glue you need for a module. You have to declare it as a module to list its dependencies and create this function that deals with loading and unloading the module. And then that's about it. You now have a module, and then they walk through what the code does. The open doesn't have to do anything. It just returns 0. When you write data, it has to, create a buffer, copy the data in from user space into the kernel, allocate some memory to put it in, use it up. Then it's going to, when you call the read function, it's going to do the randomizing, copy it back out from the kernel into user space, and return it to the user. So the article kind of explains line by line how to do this stuff, how memory allocation is slightly different in the kernel and how that works. It describes the process of using UIO to copy data back and forth across the user space kernel barrier. It even then walks through creating the makefile so that you can actually compile the module and load it. And then they create a simple user space program. You can see here, that's actually going to open dev rperm, write some data to it, and then read the random data back. And that shows you what it's going to look like.
Mm-hmm. Yeah, that's a nice interaction between user space and kernel. And once you reach that stage in the programming, if you follow the tutorial, then you pretty much know what the differences are and how these two interact, the kernel and the user land. And if you're interested in...
it's almost exactly the same on FreeBSD. I've created a kernel module recently to benchmark some stuff. So I just wanted... It's like, when this module loads, just do this and then, stop, and then you can unload the module. It's actually not as hard as you would think. It's just a little less forgiving. If you screw something up, you will crash the system.
Of course, so it's the kernel.
Kernel module development works much better in a VM, whether that's Beehive or VirtualBox or whatever. But
and in the boot environment.
Yeah.
If you want to get more information about device driver writing, there is a book by Joseph Kong, FreeBSD Device Drivers, on No Touch Press. That has more information about and walks you through some of these kernel modules. Not just a simple one like this, but even more advanced ones. So yeah, this is a nice article about writing NetBSD kernel module, and people should check that out if they are interested in writing some kernel code.
This week's episode of BSD Now is brought to you by DigitalOcean. If you go over to DigitalOcean.com, you can just, with a few clicks, spin up a virtual machine in the cloud running FreeBSD or some other operating system you want, starting at as little as $5 a month, for which you get a half a gig of RAM, a CPU, 20 gigabytes of SSD back storage, and a terabyte of transfer. Plus, you can add other features like persistent storage, block storage, where you can pay per gigabyte and get anywhere from 1 gig to 16 terabytes of storage that you can run ZFS on if you want or not. They have networking features, including a load balancer, floating IP addresses, so you can move your website between different VMs to have your different environments like staging and live and so on, or to just do high availability. They have private networking between your VMs where you don't have a bandwidth limit. It's great for, separating your backend database from your front-end website and so on. They now have, in addition to their standard droplets, they now have high memory and high CPU droplets that allow you to, spend the money on the spec of the VM that you want rather than having to scale up all of the stats at once.
And speaking of scaling up, they recently posted on their blog and also on Twitter that they now support 1 million users around the world. Wow, congratulations. That's a lot of users and a lot of droplets.
Yep, they've also added a backups feature where you can keep backups of your VM for only 20% of the cost of the VM. So for your $5 droplet, it's only an additional $1 a month. They also have snapshots so that you can clone or revert your whole VM.
Yeah, just in case something goes wrong. And if you want to run a certain app.
And cloud firewalls and anything you could possibly need. Plus, all backed by a 4 nines SLA.
That should get most people running with their cloud environment in a virtual machine.
Mm-hmm. So next up, we have an article about running Dragonfly BSD on a desktop.
Which is interesting, yeah. So this is a continuation from a previous blog post on the same blog, functionallyparanoid.com, and it talks about that if you want to, or if you know how to set up a machine with UEFI and the 4 operating systems you mentioned, then the question now comes, once you set up your operating system, you now want to run a little desktop on it, so have a nice user experience there. And he started playing around inside of Dragonfly BSD and discovered to his delight that it was a great operating system with some really unique features, all with that BSD commitment to good documentation and a solid coupling of kernel and userland that doesn't exist by design in Linux. So his goal was that the desktop experience on Dragonfly BSD was to be as BSD as possibly it could be. And now that he discovered Lumina, apparently, he went with that and XDM as the graphical login manager. And he has to confess that I really like the XFC terminal application, so I wanted to make sure it had that as well. And if you toss in Firefox, LibreOffice, and OwnCloud Sync Client, and you're pretty much good to go. Where to start? Well, first you need to get Wi-Fi going. And wired networking is also something that you probably need. So to do that, you add a couple of lines to etcrc.conf for the WLAN 0 and activate WPA with DHCP and also DHCP for your wired network. Then you create your etc WPA supplicant conf and put a couple of lines in there for the SSID of your Wi-Fi network and probably not probably, but of course you use a super secret password to secure that one, the Wi-Fi. After that, a quick reboot showed that both wired and wireless networking were functional, although you don't need to actually reboot to make that working. But yeah, it works that way. And automatically assigned an IP address via DHCP. Next up is try to getting N2X with whatever Dragonfly BSD uses for its default window manager. A straight-up startx met with, shall we say, less than stellar results. Maybe he used the following command to generate a simple etc x11 xorg file. So that's pretty much your usual xorg-configure file, and then copy that to the etc x11.conf. Although in recent X11 versions, you don't even need that one because it all auto-detects the hardware and can run most systems without that. But in case if you want to add some special hints to the X11 desktop so that you want to maybe have power saving and features like that, then maybe xorg.conf needs to be edited. Yeah, with that in place, you could get into the default window manager, but I had no mouse. Oh, that's bad for a desktop environment, of course. After some searching and pinging folks on the mailing lists, he was able to figure out what needed to be done. And another edit to etcrc.conf had moused enabled to yes, the moused type to auto, and moused port to dev PSM0. Another reboot, and he was able to get into a basic X session and has a functional mouse working. Next up, installing and configuring Lumina. Well, that's actually quite easy. You just do package install Lumina, and wow, there it is. Really, really hard, right? And I need to make a pause here to catch my breath. Of course, that's given. Next up, jumping into Lumina from the console. To do that, you create a .xinitrc file, so that one is hidden, and has the following concept: exec start-lumina-desktop, and that should automatically run Lumina once you hit up start X. And when you do that, you find yourself into Lumina, and that's pretty much the standard way of running things. You can also...
and then it goes through setting up the XDM login manager and making that start the Lumina instead of the regular one. Walks through installing the XFCE terminal, and then actually walking into the all desktop settings and actually tuning things the way I like.
Yeah, that's pretty much, I don't have any desktop environment. How can I get this running? If you follow this tutorial or this blog post, then you can pretty much get the same desktop experience. It should also similarly be on FreeBSD, I guess, because some of these commands are pretty much the same.
Yeah. So then they installed the own cloud client, Qt's Keychain app, Evolution, which is the mail client, Firefox, and LibreOffice. And there you go.
Yeah, that's a nice introductory blog post about what's the whole graphical stuff everyone's talking about. I only see a terminal. Yeah, check out the blog post and see if you can run your own Lumina desktop in no time. So this is the time for our news roundup this week, starting with porting NetBSD to all-winner H3 system on chips. That's on the NetBSD blog by Jared McNeil, and he writes, a new Sunxi, Sunxi, EVBARM kernel has appeared recently in NetBSD Current with support for boards based on the all-winner H3 system on chip. The H3 system on chip is a quad-core Cortex A7 system on chip designed primarily for set-top boxes, but has managed to find its way into many single-board computers, or SBCs. This is one of the first EVBARM ports built from the ground up with device tree support, which helps us to use a single kernel config to support many different boards. And to get these boards up and running, you first need to deal with low-level startup code. For the Sunxi kernel, this currently lives in sysark evbarn/sunxe. I don't know how to pronounce this, but I guess people will correct me if I'm wrong. The purpose of this code is fairly simple. Initialize the boot CPU and initialize the MMU so we can jump to the kernel. The initial MMU configuration needs to cover a few things. Early on, we need to be able to access the kernel, UART debug code console, and the device tree blob DTB passed in from uboot. We wrap the kernel in a uboot hex header that claims to be a Linux kernel. This is no accident. No. This tells uboot to use the Linux boot protocol when loading the kernel, which ensures that the DTB loaded by uboot is processed and passed to us in R2, which is register 2, I guess. Once the CPU and memory management unit are ready, we jump to the generic ARM FDT implementation of init-ARM in sysark evbarm-fdt_macdep.c. And the first thing this code does is validate and relocate the DTB data. After it has been relocated, we compare the compatible property to the root node in the device tree with the list of ARM platforms compiled into the kernel. And the all-winner platform code lives in another path linked in the show notes, and the Sunxi platform code provides system-on-chip specific versions of code needed early at boot. We need to know how to initialize the debug console, spin up application CPUs, reset the board, and so on. And it goes on a little further down here, stating that once the CPU... we had that already. Instead of writing H3 specific code for spinning up application CPUs, he took advantage of uboot's power state coordination interface implementation, a PSCI, and there's a driver and was added to the all-winner Sunhi-3 platform and code that was modified to use this code to start up all processors. And with a bit of luck, we're now booting and enumerating the devices. Apart from a few devices, almost nothing works yet as we are missing a driver for the CCU. The CCU in the all-winner H3 controls PLLs and most of the clock generation, division, muxing, and gating. Since there are many similarities between all-winner system on chips, so I opted to write generic CCU code and then SoC-specific front-ends. The resulting code lives in sys/arc/arm/sunxe, generic code as sunxe_ccu.c, and H3-specific code in sunhi_h3_ccu.c. Wow, this looks like a little bit like technobabble, but the people who are familiar with it and know porting to a different architecture, especially NetBSD folks, I guess, will know what I'm talking about.
Yep, and then it's got a verbose D message, so you can actually see what it looks like as it boots up.
Mm-hmm. Yeah, so this is something people want to look at if they are porting to a new application or to a new platform and want to see what's needed in which direction or in which order you need to initialize these different devices. Because it all seems so simple once you boot the stuff, but someone has to get it working in the first place, and that's the difficult part, especially if you don't have any documentation about the platform.
Mm-hmm.
So good stuff happening on NetBSD front in that regard. And other good stuff is also happening at our other sponsor this week, IXsystems, because they're the ones.
Like we mentioned during the ZFS article there, they now have an all-flash version of the TrueNAS that you can get for less than $10,000. You know, when you hear all-flash storage appliance, like enterprise storage appliance, you're pretty much assume there's one more zero than that, but not the case. You know, that's why you should definitely talk to the people at IX. On top of it, they'll tell you or help you decide what mix of devices you actually need. You know, do you need all flash, or can you get the performance you need without it? And in particular, what's the right way to go? Tell them what level of performance you actually need. You know, I need at least this many IOPS to handle the number of VMs I have. Or I have so many VMs that each need at least this many IOPS, and I'd like some more, and I need room to grow by this much. And they will help you build a system that has that level of performance as a minimum rather than a maximum. And, you know, they will decide whether that should be all SSDs or if you should go with, spinning disks and lots of RAM, or what the best approach is actually going to be. And importantly, unlike the guy writing the article about ZFS being old and stale, actually know what type of device you want to use for an S-Log versus what type of device you want to use for an L2 ARC. You know?
Yeah.
IX has been on top of ZFS since it came into FreeBSD, and they've definitely have more experience with it than most people. So they know more about it than some other vendor. So if you want to buy hardware to do ZFS, you should talk to them first.
Yep. From big servers to small servers for home.
IXsystems.com/BSD Now, and they'll build you the latest and greatest stuff. If the new Intel naming scheme, where they've renamed all the processors after types of metal, confuses you, like it confuses me, they actually know what's what and which one you want. So leverage them, right? They get all this white glove. When you talk to somebody about buying a server, you're talking to an engineer, not a salesperson. There's a difference.
A great
Mostly,
difference.
they'll actually know the difference between a silver and a bronze Xeon.
Yeah, they will also recommend you stuff that will work better together than you originally thought. They have the experience, they have the knowledge about that.
They can take the mystery out of it. They know what devices have the best drivers for open source operating systems.
Yep.
And they have relationships with, the companies that make the controllers and the disks and firmware and everything. You wouldn't think it makes that big of a difference, but it does. Just trust me.
Yeah, so check out IXsystems.com.
Give them a chance. I'm sure you'll be happy.
You'll be, pleasantly surprised. Okay, something related to IXsystems is, of course, TrueOS. And we have something from the TrueOS community spotlight, reset ZFS replication using the command line. And that's a blog post on the TrueOS website. By who? I don't see it right now, but we'll just read it here.
So it was posted by Tim, probably more, but it's documenting Brad Alexander, who actually documented his experience with having this problem.
Oh, good. It's not just people writing a lot of problem reports, but also how the solution went. And then people can find that and use the same solution. That's why it's important that people write up their experiences. So it starts off with, we'd like to spotlight TrueOS community member Brad Alexander for documenting his experience preparing ZFS dataset replication with TrueOS. Thank you. His notes are posted here, and they've been added to the TrueOS handbook troubleshooting section for later reference. Even better. Original indications. So the sysadm client tray icon was pulsing red. Wee, wee, wee. Right-clicking on the icon and clicking messages would show the message, failed replication task on your machine name to another IP address with a log file giving more information, which was lifted from varlog elp preserver, which is the live preserver on TrueOS. The elp preserver log has more information. Looking into that, it says that the send didn't actually happen, or did the estimated size is 0, so no useful errors were being written to the elp preserver failed log. And to repair the replication, his first attempt was that he tried to use the sysadm client, He clicked on the dataset in question, then clicked initialize, and after waiting a few minutes, he clicked start. He started immediately, or he was immediately rewarded with another pulsing red icon in the system tray and received the same error message as above. Okay, second approach is a little bit different. He was working with, and want to especially thanks Rod Myers and Norwegian Rockcat, so these are the Twitter names. They suggested he used lpreserver command line, so hit up the terminal and issue these two commands. lpreserver with sudo, of course, replicate init, his machine name and the IP address, and another one replicate. So the first one is the initialization, and the second one is the run from lifepreserver. But unfortunately, the replication failed again. I got a few messages in the log, something about operation not permitted, even though he was running this root permission. Failed creating a remote data set. That's an indication. I think we had that as a question a couple of weeks ago as well. It turned out there were a number of children. I logged into Luna, the free NAS, and issued the command as root. So ZFS destroy -R for to get all the recursive ones below those.
Yep.
His machine name and some of the, maybe that's just the machine name that the dataset is called. And then he ran the replicate init and replicate run commands again from the TrueOS host, and replication worked. It has worked continued to work, and at least until the next fiddly bits break. Okay.
Props to him for naming his servers after ships from Star Trek.
Yeah, it's NX something, and I recognize some of these.
Yes, so the first one there, NX 74205 is the Defiant. NCC 1764 is the an older ship called Defiant from the original series rather than from DS9. And then, yes, Yukon is the USS Yukon, and then there was another one, the USS York, or Luna, and so on.
Let me guess.
You can see they all have host names, so he doesn't have to remember the numbers. But
yeah, and a true Star Trek fan would have known that without looking.
Yes. But
for the actual problem,
it's an interesting idea. So naming the pool after the machine without having to try to fit the whole machine name in by just using the ship identifier number.
The unique ones.
Yeah.
Yeah, our cluster nodes in the big data cluster are called city names from Game of Thrones, which is even worse, but similar things. And they're grouped together in like the North, the Dorne, Westeros, and Essos and stuff like that. But yeah, moving on.
Yeah. My problem with a lot of those was always dealing with the spelling and so on. So my server cluster was just the NATO phonetic alphabet.
I remember. Yeah, you had
easy to spell and very clear to read over the phone, which are the two things I was most worried about with host names.
Yeah, if you are globally distributed, then you have to call up the data
but
center.
Also, in this one, it's not for globally distributed. They're all in the same rack. But having each server start with a different letter is also great for like tab complete and so on.
Oh yeah, that can help.
So you don't end up with like 6 servers that all start with like the letter B.
Yeah, at this point it's just the discussion about cats versus cattle, pets versus cattle.
Yes.
But the number of machines that I currently have is still handleable with unique host names.
So yes, my servers scattered all over the world are airport code number dash number.
Okay, so that's pretty much the issue and the solution for that. And yeah, good write-up, and the solution might help other people who are in a similar situation.
Next up, we have an undeadly article from Theo Durat about the kernel relinking and the status of that. He says, as you may have heard or seen mentioned in an earlier article, on recent versions of OpenBSD snapshots, you have curl, or kernel address randomization linking, or something like that, which means that the kernel is relinked on each boot, and it comes with a new kernel where the .o files are linked in a different random order with different random offsets. So he summarized in a status message on the tech mailing list. He This is 5 weeks ago at the D2K17 hackathon. I started work on randomized kernels, and I've been having conversations with other developers for nearly 5 years on this topic. So if you remember back to Peter Hessler's recent article about his first OpenBSD hackathon, you know, he was talking about Theo talking about this back then. But he says never got off to a good start, and probably because I was trying to pawn the work off on others, as he was to Peter back then. So having actually done this, I really had no idea we'd end up where we are today, and here are the behaviors. The base set has grown and now includes the link kit. At install time, a unique kernel is built using that link kit. At upgrade time, a unique kernel is built. At boot time, a unique kernel is built and installed so that the next time you boot, it'll be a different kernel than this time. If someone compiles their own kernel and uses make install, the link kit is also updated so that the next boot will still work. If a developer CPs a kernel into /, the mechanism disengages until a make install or upgrade is performed in the future. This way you can do debugging, right? You can have a consistent kernel if you actually need to debug something and have, you know, if you're trying to reproduce an issue, having the kernel jump around every time is probably not going to help. It goes on to say, a unique kernel is linked such that the startup assembly code is kept in the same place, followed by randomly sized gapping, followed by all the other .o files in a random reorganized list each time. As a result, the distance between the functions and variables is entirely new each time. An info leak of a pointer will not disclose other pointers or objects. This may also help reduce gadgets on variable-sized architectures. Causing polymorphism in the instruction stream is damaged by nested offset changing. At runtime, the kernel can unmap its startup code. On architectures where an unmap isn't possible due to large PTE use, the code can be trashed and overwritten instead. I did most of the kernel work on AMD 64 first, and then over to i386. I explained that needed to be done to Visa and Patrick, who handled ARM and MIPS platforms. Then I completed all the rest of the architectures. Some architectures are missing the unmap/trashing of startup code, and that's a step that he needs to get back around to finishing. He says, however, the next part was tricky, and I received assistance from TB and RPE. We had to script the behavior at build time, snapshot time, relink time, boot time, and later for the install and upgrade time. While they helped, I also worked to create the new gap.o file without use of a C compiler, so that relinking can occur without the compiler set installed. This uses the link script feature of LD. I don't think anyone has done it this way before. It's a little bit fragile, and various linkers may need to receive some fixes due to what he's encountered so far. To ensure this security feature works great in the 6.2 release, please test the snapshots. By working well, I mean it should work invisibly without any glitch such as a broken kernel or anything. If there are ugly glitches, we'd like to know before we pull the release. So yes, Theo's asking that people go out and test the snapshots and make sure that every time they reboot, even when they've frobbed some things, they get a fresh kernel and that it just works.
I mean, we covered Carl just 4 episodes ago. I just checked, and seems like there's a lot of work going on. I have a hunch there might be a conference talk coming up about this, which might be interesting to watch, because this is interesting stuff. And now it's time for our Beastie Bits this week, starting with Beta Undeadly Call for Testing. Wow, this sounds interesting, but it's also on undeadly.org from the Better Late Than Never Shut Up and Code department. Oh, this is cool.
So this is from the OpenBSD journal website, basically, and they have a new version of their website that has a bunch of features, and they would like to test it. First of all, it's HTTPS only. They've kept it to simple HTML and CSS. They used standard HTTP error codes instead of anything else. They have increased the cryptography on everything. They've made use of pledge and so on and KCGI for the sandboxing of all the HTTP REST stuff. They've replaced the search facility with some other stuff. They've fixed the RSS feeds. They've removed comment modes. Comments are now displayed as nested ordered list, as natural, or as nature intended, and so on.
It's nice that, I mean, OpenBSD journal and undeadly.org has been around forever, I think, and giving it a little facelift and update behind the scenes is well worth doing, I guess.
Yes. So maybe if you go to read that curl article, or Carl, you can do it on the beta site and see if make sure everything works right.
Yeah, and report something that you find back to them so that they can fix that. Okay, next up is our favorite author of BSD books and articles and blog posts.
I thought I was our favorite author.
Well,
teasing.
Well,
Michael Lucas is definitely our favorite.
We'll take that offline. No, it's about Michael W. Lucas giving us an update about Absolute FreeBSD 3rd edition update. So actually, I've read a couple of those chapters because I'm one of the, not the only one, but one of the proofreaders for the new chapters. So those that are ready or ready-ish, they look very, very good. So people can already look forward to the 3rd edition of Absolute FreeBSD. He starts the blog post with, I'd like to have the 3rd edition of Absolute FreeBSD in print by May 2018 for BSD Can. And after discussing with No Such Press, which is doing that one, and also did the 2 before that, to make that happen, he must complete the first draft before November 2017. That's 4 months. To complicate things further, in those 4 months, he has 4 weeks of traveling, BSD Cambridge, EuroBSDCon, and a writing business workshop. So 3 months. His best guess is he has to write about 15,000 words a week to make that happen. Wow, that's a lot. Call it 3,000 words for a working day at my nonfiction cruising speed, about 500 words an hour. That's roughly 30 hours a week or 6 hours a day, provided nothing goes wrong. Whew, wow, that's ambitious.
At that rate, I would have written my half of each of the ZFS books in less than 2 weeks. It doesn't work like that.
Oh, yeah. I mean, it's not just the speed, but it also has the usual quality, and footnotes have to be funny, of course. And for the chapters that I've read, they are in there and they're funny. And if he keeps up writing that way and the rest of the chapters will be the same, then that will be an absolute amazing book to read with all updated FreeBSD things in there for FreeBSD 11 and good stuff and new stuff as well, not just rewritten stuff, but all the good things about FreeBSD 11, the features are described in there.
Yeah, so he actually has a more up-to-date update. I'm looking at here. He says, for those who are watching as he writes it, here's some things, how things stands. It's currently at 77,400 words, with 7 of the 24 chapters being done.
Yeah.
Yeah. As first drafts, anyway, and 3 more chapters are partially done. So if 77,000 words is, 10 out of 24 chapters, that's still a lot to go. The current outline looks like this, although the chapter titles are subject to change. For reference, the ideal chapter length is, for this type of book, is about 5,000 words with 24 chapters here.
It's a tome.
So starts with chapter 0, because he numbers from 0 like is intended. Then he's got, an introduction, then getting more help. So, if this book doesn't answer your questions, where to keep looking. Pre-install considerations, things you decide before you run the installer. Then installer, which he's going to write last because screenshots are evil, yes. Then booting and how it works and dealing with serial and serial over LAN. Then backups, the kernel, networking, configuring Ethernet, security, partitioning in geom, which is apparently 10,000 words, so double the size of an intended chapter. UFS, 8,000 words. ZFS, other file systems, more security, etc, packages, ports, software management, upgrading, small system services, performance, jails, miscellaneous crap, and panics and bugs.
Yeah, it's good. It's a good book. I mean, as far as I can see from the chapters that I've read already, it's going to be a great one. So people look out for that next year when it's coming out. And Godspeed, Michael, for the rest of those chapters, and let nothing keep you from writing. Okay, next up is a new home for the NetBSD repository conversion. So Jörg Sonnenberg writes on mailindexnetbsd.org. Hello all, the repository conversion startup for NetBSD CVS to Fossil to Git has found a new home, ironically on former cvs.netbsd.org hardware. This provides a somewhat faster conversion cycle as well as removing anon cvs.freebsd.org from the process. This should avoid occasional problems with incomplete syncs, and 2 other changes have been applied at the same time. So the Fossil repositories have moved to using the SHA-512 checksums internally, and to avoid accidents, a new project code is used. This requires Fossil 2.x, and the Git repositories map usernames to @netbsd.org addresses for source and X source, or at packagesource.org addresses for package source. This allows consolidation of GitHub with user accounts, assuming you have the corresponding addresses as primary or secondary address. And he provides the links to the new locations for people to check out. So this is an interesting conversion from like CVS to Fossil to Git, because there's always discussions in FreeBSD going on about, well, Git and no Git. And this is actually something to watch because other BSDs have similar...
Well, I think this is just an exporter similar to how FreeBSD does GitHub. I don't think it's actually switching their repository of record. Although maybe, I don't know. Anyway, next up, TrueOS has an update for their unstable version. So they now have a new unstable version of TrueOS released regularly. The unstable branch is a full rolling release of TrueOS. Unstable includes experimental features, bug fixes, and other current features from FreeBSD. It is meant to be used by those users interested in using the latest TrueOS and FreeBSD development to help test and improve these projects. This is the first true unstable update since the 6-month stable images were released back in June. Previous unstable updates from June and July were maintaining parity between the 2 tracks. Now unstable is ready to break away from stable and fulfill its development goals and have, experimental rolling release and be full-featured version of TrueOS. Warning though, unstable updates are released primarily for TrueOS and FreeBSD testing and experimentation purposes. Update and run unstable at your own risk. Current TrueOS users can update using the built-in update manager. Users already on unstable need to run pc-update manager syncconf at the command line to properly switch over to the new unstable repositories, which have a different URL. An alternative method is to switch from unstable to stable and click save in the update manager, and then switch back from stable to unstable and click save again. The new unstable ISO and image files, beginning with TrueOS 2017-0714, are available for download from downloads@trueos.org. As of now, unstable and stable TrueOS ISO images have the same naming. This is going to change very soon, but for the moment, users are cautioned to keep their unstable download ISOs separate from their stable download ISOs so as not to mix them up.
Okay.
They have a quick notes on what's going on here. It's updated to FreeBSD current from June 22nd, and has a ports synced from July 11th. The modules now load before running the sysctl init.d script, so that any sysctls that don't exist until the modules load still work. The TrueOS server and TrueOS desktop now select the proper package repos on loading, which is affixed to the installer. You got some LibreSSL patches, an OpenRC script for OpenVPN, lots more OpenRC service files for random services, some updates to the PC Update Manager port, and added an extra option to FFmpeg. And they've integrated the FreeBSD inode 64 patch, so that's there.
Okay.
One known issue is that VirtualBox is having problems. They're still working on that.
But I hear VirtualBox now has the ability to do shared folders with the host operating system.
Yes, I need to look at that.
Changes.
That's Mohi.
It's been a while since that worked, and now it's working again. So
Yes, and it was glad to get to talk to the people that were working on that at the SNDev Summit.
Yep. Cool. Next up is an interview with George Neville-Neal, president of the FreeBSD Foundation, not the FreeBSD project. It's from Mapping the Journey, which is a blog about unmasking the people who are making, it's a blog podcast. There's a little show note right up as well. So Mapping the Journey is basically people who are making tremendous strides in tech, yet whose stories are seldom heard. And they interviewed in their episode 4, George Neville-Neal. And the questions are in the show notes there. And yeah, it's quite a good rundown of basically everything that he does, how he got started with FreeBSD, the book he has written, his work on the ACMQ magazine and the FreeBSD journal, and pretty much everything that he's doing in the networking area and FreeBSD specifically.
Yeah, there's some other interesting interviews on there as well. Episode 1 was with Rich Sauls of the OpenSSL core team. Episode 2 was Alex Martelli from Python. Episode 3 was James Gosling, who's the father of Java. Then episode 4 was George Neville-Neal, and the next upcoming episode is with Bjarne Strostrup,
I guess,
who's the creator of C++. So, some pretty fancy interviews in there.
Mm-hmm. Yeah, so check that out.
In the roundup, we have the release of LibreSSL 2.5.5 and 2.6.0, which are available on your local OpenBSD mirror. LibreSSL 2.5.5 is derived from the stable branch tracking OpenBSD 6.1, while LibreSSL 2.6.0 is the first release of the development branch that will ship as part of OpenBSD 6.2.
Mm-hmm. Okay. It's always good to see LibreSSL updates and news in that area. Good stuff. So before we go into our feedback and questions section, it's time for our sponsor for this section. It's Tarsnap.com. Go to Tarsnap.com, the online backups for truly paranoid people and less paranoid people maybe, but they all have the same problem. They want to do secure online backups. And the way to do this is with Tarsnap, of course, because you are the only person holding the key to your encryption, because you do that locally before you push this into the Amazon cloud in this case, and no one else, not even the Tarsnap creators, can get to your data because you're the only person holding the key. There's a bunch of clients available for various operating systems, the Linuxes, the BSDs, the Windowses of this world, and so that should be something for everyone. Tarsnap is very secure. It gets frequent updates and should be your first go-to place for your all backup needs that you might have. So check out Tarsnap and tell them we sent you. Okay, now it's time for our feedback section, which is the section that some people are looking forward the most. Today we start with Jason. He has a Beehive VM UEFI question. There are some woes in here, I guess. He writes, "Gents, I've hit a bit of a sticking point with FreeNAS 11 and the Beehive VM I'm running. I originally configured this virtual machine as a Ubuntu Linux 16.4 host with a ZVol of 16 gigabytes. There came a point where I needed more disk space. So I expanded the ZVol to 32 gigabytes and booted the virtual machine. His intent was to boot and make the necessary alterations to the swap and data partitions and extend the primary data partition as well. I was highly displeased to find that the UEFI had lost his settings. I ended up booting into an ARC ISO and rooting into the Ubuntu installation. What he discovered was that he had, as suspected, that the output of EFI boot manager command showed no sign of the prior grub EFI configuration. So he proceeded to reinstall grub EFI and just to be dead certain ran grub-install himself and then checked out the output of EFI boot manager again. Now he has his entry and grub claims everything is well. All is well, yes. Nope. Time for a host power cycle as I'm installing additional drives. Upon power up and consecutive start of the VM, no more EFI settings. Repeat booting the ISO, change root and EFI boot manager, run grub install, run EFI boot manager, run reboot commands in the VM. and that works. Reboot in the virtual machine works. Sudo power off, go back to the FreeNAS UI, start the VM, poof, no more EFI. More interesting, the EFI shell, version 2 in this case, if you're wondering, recognizes the FUD partition but finds nothing in it. Yet if I enter the EFI manager by mashing the key press at boot, it can see that the ESP partition and access all the content in order to add an entry in this fashion as well. However, that does not survive a power cycle on the virtual machine either. What in tarnation is going on here? Please help. I can keep the zvol and recreate the virtual machine, but the engineer in me really wants to know what the heck is happening.
I wasn't aware that Beehive had a way to store EFI variables at all yet. Switch. Did power cycling work fine without resizing the zvol? Or did you only ever boot it once and then?
Does it say? I don't think. Is that a sparse zvol or is it a non-sparse one? Or doesn't
zvol
matter in this case?
There's no difference in a zvol.
Oh, well, yeah. Anyway. This is something maybe that needs to be
like in a real computer, those EFI variables are stored in like NVRAM on the motherboard, not on disk.
Yeah.
And I don't think Beehive emulates that. I'm not sure.
Might be something for the Beehive developers.
I've really booted many Beehives with EFI, honestly. Almost all my Beehive are FreeBSD, so I've just, used Beehive load.
Yeah, I would recommend running this in the FreeNAS forums. Maybe someone else has encountered this. Or hit up one of the Beehive developers. Maybe they have similar experiences. But it's something we're checking out, especially once people start running more Linux installations in their Beehives. I never had that problem, but I also do very little in the EFI space currently. Might change in the future, but at this point I'm pretty much out of ideas. Maybe some of our listeners can help. Sorry, there's no help from our side, I guess.
Yeah, I'm not that familiar with those particular bits of Grub, or of Beehive and EFI. It would be worth finding out if creating it fresh solves the problem, and if not, I'm dead. But I don't know where Beehive tries to store the EFI variables or whatever.
Yeah, maybe it's not implemented yet, but it's just a guess at this point. Moving on. There's a message from Donald with several questions. He writes, "Hi Alan, directly. Thanks very much for contributing to that Phoronix thread. It's always nice to hear from someone who actually knows what they're talking about in such discussions. He has some good news. I'm currently looking into switching away from Arch to using TrueOS as my main OS at home. I've already been running FreeBSD 11 on my NAS for a year or so, but last night I was testing some stuff under Arc. I installed a bunch of packages and desktops only to find my install borked upon reboot. I couldn't even get to a login prompt, never mind X. Not good. Where are my ZFS boot environments when I need them?" Yeah, that's what I'm saying. Not under Linux, at least not without a lot of messing, and ZFS is poorly supported under Linux in comparison to FreeBSD and TrueOS, as well you know. Yep. So I stayed up late night and I installed the latest TrueOS. I'm happy to report that one major potential hurdle to me adopting it as my main OS at home has successfully been cleared, as my Haswell GPU is working fine, as I have successfully tested the playback of a few different 4K H.264 videos under MPV without breaking a sweat or dropping frames on my UHD external display. A promising start. I have not tested the Wi-Fi yet, but it is showing nearby access points, so I presume that works, and I use a wired connection at home, so that's not a priority for me. All my hardware seems to be working so far, and I think there are just one more thing I need to get working to switch from Linux at home at least, and that is MTP support, so that I can easily transfer files to and from my Android LG G4 phone via USB. Last time I tried it under FreeBSD when 11 was in testing, I failed to get any of the various FreeBSD NTP clients to work. So I'm hoping there's been some progress in that respect under 12 and ahead. Oh, that reminds me, you have an MTP, there's a little how-to addition for the handbook to add MTP instructions to it. I need to put that in.
Might be just what this guy's looking for.
Yeah. He continues, I'll be testing this tonight so I can let you and Chris, that's been a long time actually, know how I get on later. Ideally, I'd like to switch my workbook from Linux to FreeBSD/TrueOS too, but there seems to be a blocker there, and that it is just I need to be able to use a USB headset with Skype for Business under a Windows virtual machine. This works great with both QEMU and KVM and VirtualBox under Linux, but it doesn't seem that it's impossible or that it's possible on the Beehive for FreeBSD yet. His research tells him that it's only possible on the Beehive if you have the right type of USB chipset as a PCI device and you are able to pass that through, but that's not an option for him. His workbox doesn't have any PCI slots. And as far as he can tell, USB pass-through used to work on the FreeBSD with VirtualBox, but is no longer that case. I don't suppose you have any suggestions to potentially get USB pass-through working in a Windows guest.
Well, there is Zen, the hypervisor. I don't know about USB pass-through specifically on it, but
there are some features that aren't supported yet on FreeBSD. They're working hard on making that on par with Linux.
Those are relatively specific, I think.
Yeah.
Other things. I donated a webcam towards getting USB pass-through working for Windows guests and Beehive, so hopefully it'll show up soon. But yeah, in the meantime, best bet is probably...
I also need to do some
Zen?
testing with... Yeah, Zen might be a better way to get started. Shamelessly plugging my ZFS how to in the FreeBSD handbook here.
Yeah, the other thing I was going to say was, I think USB pass-through works in FreeBSD in VirtualBox, but only for USB 1.1, not for 2.0. I don't know. I've never tried to do it.
Mm. Yeah, and for the MTP stuff, no, how hard could it be? MTP, there's a bug report in the FreeBSD Bugzilla about it. If you want to look that up, you might find some instructions there that might help you. They might be outdated a little bit, but I need to mush that into the handbook chapter. Okay, hope that helps you a little bit. And we continue with Dan, who also has several questions. He starts with, I've just written this lengthy geeky ramble about why I've recently decided to switch to TrueOS from Arch Linux on my laptop, which is my main machine at home. It could provide good material for BSD Now. Yeah, by all means. After our 20 years, that's a long one. So he starts, after over 20 years of using Linux as my primary OS at home, I have now ditched it in favor of FreeBSD TrueOS. TrueOS is a version of FreeBSD customized for home desktop computer users. The main reason is that no Linux distro supports ZFS as well as FreeBSD. See, that's the theme of this whole episode. And TrueOS do, and I value ZFS boot environments so much that I'm willing to switch OS to get them. Yes, that's the spirit. The crunch came on Monday night when I ended up installing multiple desktops and many packages in a row under Arch. Something went horribly wrong around the way, and I couldn't even boot to the minimal rescue prompt and tried rebooting. That sounds similar to the previous question, actually. Seems like a problem in Arch, I guess. So this is exactly the sort of scenario where boot environments save you hours of reinstalling. Yes, they do. Or messing around restoring backups.
Yeah, you do have to remember to create them, though.
Yeah, don't just wonder whether they are created. You need to do them.
You know, and every time you make a change and things are still working, create a boot environment.
Yeah, but if you have them
back, you only have to redo a minimum amount of work.
Yeah, you just boot to the last known working boot environment, like nothing ever happened, and you're back to where you are in a matter of seconds even. There are various disaster recovery mitigation things I could do under Linux, like using Rear, Clonezilla, etc., but none of them are as painless, fast, and elegant as ZFS boot environments, and boot environments don't involve you using external drives or network shares. Boot environments also allow you to install whole new operating systems without messing with your hard drive config. There's no unusing them or forgetting how better your computing is having them once you've experienced their power. Wow, yeah. We couldn't have said this better.
In particular, you know, if you do break something, maybe you want to try to fix it but maybe you need to give a talk at a conference right now. Reboot
Same thing, yeah.
older boot environment, give your presentation, then reboot back to the broken system, figure out how to fix it.
Mm-hmm.
Or, we were just talking about TrueOS and using the unstable branch. It's like, well, I'm going to run on the unstable branch and help the developers and find problems. And, the thing I want to do doesn't work now. Okay, reboot back onto the stable branch, do my work. Oh, they fixed the problem, go back to unstable branch, update, work again until I run into a problem, then fall back or whatever.
And it's also a nice learning experience trying to fix things you broke and learning a lot about how things work the way they do and trying to put them back together again. The question that he's now asking is, he has been trying FreeBSD on and off for the last 2 decades. It doesn't support as much hardware as Linux, but I'd have to say that if all your computer's hardware is supported and it has the software to do what you want them, then it's the best choice. This was my problem until very recently, because although I had badly wanted ZFS, FreeBSD and TrueOS didn't support his laptop's graphics card, and so he couldn't play videos. That has been fixed on recent TrueOS releases, and now his laptop's Haswell GPU is fully supported so that I can play 4K videos smoothly via HDMI with MPV. I like ZFS a lot, but you can't have a usable desktop computer without video playback. Oh yeah. That was one major blocker to me using FreeBSD at home, and the other was MTP support. Here we go again. That might be the same solution for you. He tried, but didn't get MGTP, a graphical app for transferring files to his Android device for Unix. And yeah, this might be a similar issue. We just skip over this. The other feature that FreeBSD is famous for is its superior networking stack. Up until the last few days, I was taking the FreeBSD advocate's word that it was better than Linux at network stuff, but now I have first-hand proof. I have a crappy broadband connection in my flat as I rely upon a powerline broadband adapter to pipe the broadband from his landlord's house to his flat. Under Linux, the connection would frequently drop or stall for a number of minutes, but I've had no such dropouts under TrueOS. My internet has been rock solid, if still slow, since. Oh, that's good to hear. Whilst I will still be using TrueOS or FreeBSD as my primary OS at home, from now on, it doesn't mean I can't get rid of Linux yet. At home, it will do a boot because there is a fair bit of software that is available for Linux, but not FreeBSD. In this case, the main non-FreeBSD apps I'm interested in are Reaper and the IXsystems, but there are certainly other things too. You can run some Linux apps under FreeBSD, but it's not 100% compatible, kind of like Wine is for Windows apps under Unix. I will continue to run Linux in work because FreeBSD notably trails behind Linux for virtualization. None of the FreeBSD Word solutions, Beehive and VirtualBox, have working USB pass-through, and hence I'm unable to use apps such as Skype for Business under Windows VM, which is the only real reason I have a Windows virtual machine in work.
Yeah. Again, this is why I donated that webcam to the Beehive developers, because everybody needs Google Hangouts or Skype for some work thing. And so getting that going is exactly what we're after.
Yeah. And for the networking stuff, you could also run FreeBSD as a router or as your main internet gateway and have the superior network stack.
Although in this case, it seems his landlord runs the router. But anyway, last question from Bryson. He says, "Gentlemen, let me start by saying thanks for the awesome show and keep up the great work." He has 2 questions. First, I'm including a Reddit link to my question because Reddit provides much better formatting tools than the email client. Okay, I guess I didn't actually...
Oh, there's a Reddit question? We jumped to that.
I didn't actually see ahead of time to...
That's fine.
We just read the question.
Do it on the fly.
Updating base OS from 10.3 to 11, and now when he runs package inside the jail, he gets libcrypto.so.8 not found, required by libarchive.so.6. So...
that's a known question, or a problem.
Looking at it, one second, I'm just looking over what he did. Right, so he's installed new... Yes, he's updated the OS in the
jail only
as well. Okay, so likely what you want to do is run pkg-static install -f pkg to update the version of pkg so that it matches what's installed in your system there.
Yeah, so both have to be in sync, the host and the jail virtual machine, or the container. Yeah, there are a couple of instructions there.
Oh,
in
no,
the
it
Reddit
says he
thread.
tried package static install -f package.
Oh, and that didn't work? Well, that's where the linker errors probably came from, the shared objects not being found.
Right, I'm guessing your best bet there is to double check that inside the jail you actually have the version of the OS that you think you do.
Yeah, but can't you just recompile those ports within the jail?
You could install a package from ports, but well, it actually doesn't work if you don't have a working version of package. It gets very complicated, but yeah,
it's a little bit.
pkg-static should work as long as your package.conf points to the right version. You definitely want to run FreeBSD-version and uname minus capital U and capital K, and make sure that your jail is actually all the way upgraded to 11 and not still got some stuff that's 10.3.
Maybe delete some of the older. We'll do the delete old step as well, because there might be some old shared links, shared binaries, or shared
Well, in this
objects.
case, I think that's part of his problem is he deleted those too soon.
Then you usually
Really?
link to the older ones. There. Yeah. Here we go.
Yes, most likely you need to. Your jail is not as upgraded as you think it is.
He also has a second question. Or is
Yes,
that linked
this
to the
is,
one?
Inside my jail, I previously was able to install LibreSSL alongside Nginx. At some point, Nginx was changed, and I'm no longer able to install LibreSSL and Nginx together. Installing Nginx actually forces me to uninstall LibreSSL. I can't find any mention of the changelog for Nginx about requiring OpenSSL or explicitly disallowing LibreSSL. Is there another reason for this? I think the FreeBSD port enabled SSL by default, I think is what happened. It's a packaging issue, but it's not necessarily an issue with Nginx or LibreSSL. Is that LibreSSL and OpenSSL can't coexist, and Nginx is compiled against the default version of SSL, which is OpenSSL. You'd have to recompile Nginx specifically with the uses SSL equals LibreSSL in your config.
Yeah, if you are in that situation, it's difficult to get out of it, but there are ways to solve that. Especially you don't want to
basically, if you want to use LibreSSL, you pretty much can't use the official packages from FreeBSD because everything's compiled against OpenSSL on purpose.
Yeah, it's not part of the base system. That might be the problem. Okay, I hope that solves your question. And now, usually we would say goodbye at this point, but not this week, because we have a special final note for you, our listeners and watchers. Well, Alan, why don't you give that to the audience?
So we've decided to do something a little different coming up. We're going to have to record a number of episodes a bit early and out of order and so on to deal with what we have BSD Cam, and then you have another trip, and then VBSD Con, and then EuroBSD Con, all very close together, and with lots and lots of travel and extra stuff with the summits and all that. So to try to make sure we have lots of content for you guys the whole time, so you get an uninterrupted flow of BSD in your face. One of the things we're going to do a little different is allow you, the audience, to interview myself and Benedict. Maybe not at the same time. We might actually do it as two separate ones if we get enough questions. Either way, getting our entire audience live would be a bit of a challenge, especially with time zones and so on. So obviously what we would like you to do is email in questions, interview questions like we ask our guests all the time. This interview is not like the feedback questions we just did, right? We don't want your technical questions. You want questions you want to ask us specifically about things. Please indicate who the question is for, myself or Benedict or both, and we'll be able to try to divide that up and sort that out. But yes, this is the chance for you, the audience, to ask Benedict and I questions you've been wondering over the years. You know, like, why do you do this, or whatever. Or, you know, of all the conferences you've gone to, what has your favorite been, things like that.
Yeah. So sometimes people ask stuff in the chat room, and we usually want to answer that, but we don't have time during the show. So we give you some special time just to answer those questions.
Yep. And then we'll work on compiling those questions and answering them in interview style for an episode. So make sure you email feedback@bsdnow.tv with your subject viewer interview questions so that we can sort them and compile a big little list of questions for each of us. And we reserve the right to not answer certain questions, you know, inappropriate or trolling. But if you do send us trolling questions, we reserve the right to make fun of you.
In return. Yeah. Actually, we look forward to the questions. I mean, it's getting to know the community a little bit better, and you getting us to know a little bit better. So that's a win-win for everyone, I guess.
Yes, I'm quite interested in what some of the questions are that you want to know.
Yeah. So send us your questions, and yeah, we look forward to them.
Send it to feedback@bsdnow.tv with the subject viewer interview questions. Please send lots of questions, and as I mentioned, especially if they're specifically for one of us or the other, make sure you indicate which one it is for.
Yep. Okay, that's it for this week. And yeah, if anything else is coming up, then send us at feedback@bsdnow.tv your other regular questions you might have.
If you have more questions like the ones we just answered, or if you think, hey, there's this news story you guys didn't cover, well, let us know and we'll get on top of it.
Yep. So thanks for watching, and see you next week.